Hello, my name is Patel. So today my topic is about voice assistant and digital signal processing. So my name is Preet Patel from Charlotte CSPIT. My ID number is 24C091. So our first topic will be about introduction. So what are voice assistant? So basically voice assistant are about like we just speak about anything. Like I speak like I just ask to Google like Google, can you help me in making this project? So it will give me information about particular project, like its information, images, like how I can execute it. So it is like I just speak and it gives me information about it. So there are multiple examples of it, like Alexa, Google Assistant, Siri, and Cortana. Then our second will be why voice assistants matter. So like I just said that I can just go handlessly with it. So like for example, if anyone is unfortunately disabled, he doesn't have hands or like anything related to his like not having hands or isn't able to work with hands. So he can just speak up like, hey Google, can I get some information about that project? So it can give information on that project by just he won't able to type, but he will get all the information that he wants. Then it is on smart home integration. Like we can use our Alexa for integrating in our house decor. We can just install Alexa and we can wirelessly connect it to any light, any fan or AC, and we can just say that Alexa turn off my light. It will turn off the light. If we say Alexa turn off my fan, it will turn off my fan. So our third is major voice assistant in the market. So like as we know, there are like some particular object have more popularity than another. It's because of its uniqueness. So first of all is Amazon Alexa. I just said you like how we can integrate it with our home decor. So if we integrate it with home decor, it's more valuable than using Google Assistant. And we know that Apple series like exclusive for Mac only. So yeah, these are Amazon Alexa. Then we have Google Home Assistant. Then we have Apple Siri, Samsung Mixi, and etc. There are multiple products available in this market. So our fourth will be basic workflow of voice assistant. So there is wake word detection, that is signal. So like if I say hello Google, so it will detect my voice. Like I said, hey Google, it will go in the form of signal. Then it will go to capture. Then it will go to DSP, NLP, then it will go for a cloud processing. Through cloud processing, it will know that what we are just giving the signals, it will detect and it will then generate responses and then audio playback. Like it will speak up. Like if I say, give me information about this project. So it will say me like, okay, here's are the some information about the project. Here are some images. So like this work is the workflow of that. Then fifth is introduction to digital signal and processing. There is DSP. We have further seen that DSP is available. Like this DSP is need DSP. Okay, that it goes from this workflow. So the DSP is its definition is processing of digital signals to improve or extract information. So like we say now that Google give me information about this project. So it will extract information from it. Like it will gather some information that what I'm saying. So it will just take my audio or some if I upload some video of it, then it will take that video in that processing. It can take the communication systems. By this DSP works. Then sixth is importance of DSP in voice assistant. Its key role is voice clarity, noise reduction, and accurate command recognition. um, voice role in clarity means it will enhance our voice. If there is some background noise coming up, it will just clear that noise and it will accurately transfer our audio to into the signals. So our seventh is stages of DSP in voice assistant signal acquisition, that's microphone. So like it will pre-process like noise filtering. Then it will cancel the echo that is been transferred. Then it feature extractions with MFCCs and spectrograms. So it will just remove the spectrograms. Like a spectrogram is the like the miniature form of like you can say it like the waveform of signal. So in spectrogram we can just go easy, like the process goes easy, like it will just detect the signals and it will remove the unnecessary part from that voice. So like example, if I'm speaking and someone bark at in my background, so can reduce that barking, not clearly cancel that. It's done by the advanced technologies, but for basic we can just clarify that that it will remove or just reduce that barking. So our next will be microphone array technology. So what is it basically? So it's beam forming, focusing on the user's voice. Example is Echo devices having multiple microphones. So like for example, if I we know that natural its natural form is about if there is an empty room and I just speak it now, I can hear my voice is back to back. So it will like, for example, I'm speaking that, hey Siri. If my friend or any of my relative just speak, hey Siri, it won't be able to detect my voice if and only if I have not registered it. If I register it, that also will be detected. So for that, we need to detect. So like, wait a second. So then it will detect our voice and just it will give informations like not like if I'm speaking about anything and if anyone comes at back and if his voice has been detected, then it will not be easy. Like example, I am just discussing about this slide and anyone says that, hey Siri, can you please call this person, and it's called, then it's like not useful for us. Our next point is wake word detection. So always listen locally for Alexa, hey Google. So yeah, I told you like Alexa, do this, hey Google, do this. So it is like wake word, like from the telling this word, it wake ups, like it get activated. It is been come from lightweight DSP to avoid cloud overuse. Importance of energy efficient DSPs. Noise reduction and echo cancellation, removing background noises, suppressing echoes from device speaker, algorithms use, adaptive filtering, and spectral subtraction are being used for these algorithms. Our Elan will be feature extraction technology, meal frequency restriction coefficients, that is MFCCs. So I told you about spectrograms, like it is the waveform of the voices. So what features are essential for speech recognition? We will see in the next slide. So natural language processing is the point that we need to come from that this point. Like what is this essential of speech recognition? So this is natural language processing. So after DSP cleans the signals, NLP kicks in, understanding context, intel, and semantics. So like from these things, we can just make our like this picture recognition will be recognized by using these multiple factors. You understanding context, intel, and semantics. Our 13th slide will be cloud processing versus edge processing. So for first we will go with edge processing. Wake word and basic commands process locally. So like if I tell like I will just say Alexa, it will just respond me like, hey. If my name is recognized as Preet, then it will say, hey Preet. If my name is recognized as Pearl, then it will tell, hey Pearl. For cloud, there is complex queries processed on powerful servers. So like edge is like we just wake up about that. And for cloud, if we say like, hey Siri, just help me in doing this project. So that I said that help me in doing this particular project. So that is complex because I need multiple information, multiple videos, multiple images about that topic. So it will go for cloud processing and it will give more and more information to me. Then there is privacy and latency consideration. So like yeah, if we need to make a huge like a big project, then we will have to wait. Like it will just process. Like for cloud, it will just take my words. It will process. It will search. It will surf about my information, and then it will be showing to me. In this, we will also have to take care. Like if anyone is having our information about voice, it can be used as like it. He can use that voice for making any other videos. Challenges in DSP for voice assistant. So, like I said, background voice, ascent and delay case, multiple speaker, cocktail parties problem. Yeah, so like if there is some party going around and if multiple speakers are used, then our phone will wake up like multiple times it will wake up and it will just lead our draining the batteries and like it will be a huge problem for us. So for that we need to just use our multiple DSPs like a reduction of noise background, accent and electrics, and multiple factors that has been discussed earlier. Advances in DSPs for voice assistant. So like for it, we can be used for DL, that is deep learning for better noise suspension suppressors, personalized voice models. So like if I can make my voice video by just speaking a single word, this is done by deep learning and multiple uses of AI. I can just make any video from that. Multiple model assistant, combining voice with gesture recognition. So like if I am speaking like this and my voice and my gestures has been recorded, so from this just 1 second clip, I can make a full clip of like up to 10 to 20 minutes about its from its limitations. We can just make a video for multiple minutes or even multiple hours or multiple days. We can make it. It's like it is like very frequently used in this decade. Then there is 16th, security and privacy concerns. Always listening concerns. Like yeah, I said that from this 1 second video, 1 second video, they can make for multiple hours and hours. So like if my voice is being leaked, so like I am telling okay. If I just said okay, here due to of deep learning and AI, it will recognize my voice and it can be used in making of the deep like dark videos or some illegal trades. Then there is difference between local versus cloud processing trade-offs. That is data encryptions can be done for it. Real life applications, smart homes like light and thermostat. So like I said that hey Alexa, turn off my lights, then it will automatically turn off my lights. We can use it in shopping like hey Google, I need to shop this cable. Can you help me? Then it will give a link about it will give us links and multiple information about that product like what is the rating of that product from where you should try to purchase it. So where you will get it cheaper and we can schedule anything. Like, for example, I have meeting tomorrow at 10 p.m. Then I can just tell that, hey Google, set an alarm for tomorrow at 10 p.m. It will wake up to, it will just ring at the next day's 10 p.m. and scheduling is the entertainment. You can say, hey Google, can you please give me some content that makes me feel happy? So it will be giving us multiple links of the contents. It will tell like it will differentiate that what content is for what. Our 18 slide is future of voice assistant and DSP. So like context awareness, our assistants. So like for future, we can like I told you like we have some limitations that we will be able to just make 1 second video, 1 second voice from ours. So we can try to make it larger and larger. It will help for something processing, smarter offline processings. So smarter offline processing is been a very like it's like not very that aware to everyone, but we can just go for deep learning in that in that particular field, and we can just make it like a boom. Emotional recognition from voices, emotions. So like I said that my gestures. So we can just make anything gestures. Like we can just make a movie from it. Like from just 1 to 2 gestures, we can just make a movie. From that voice we will get, and our emotions have been right. So this will be uh, like we could work on that. 19. So this is the last slide. We will just take a brief summary about what we have learned in the past 18 slides. So first is key takeaways about voice assistant and you. So we have take some key takes away from like what is the DSP, what is MFCC, and multiple things. We know that what is deep learning, what we can do from voice recognition, what we can do from emotion recognition, how a 1 second, 0.1 second video can be transferred into multiple hours or multiple minutes of a video. Then future directions and ongoing challenges. So we also talk about future directions, like we can work on that to make our emotions more accurate. So like, for example, if I'm smiling, so today we can, so at this present time, we can just tell that it will just recognize smiling. If we do deep learning and multiple researches with it, we can just make a full movie of it And ongoing challenge is like we are just growing day by day. We know that AI come, then due to that multiple factors come. Like for privacy, we can tell that deep fake videos come. Like if we are not present there, there is a fake video which is being ongoing with you. Like that's not you, but it's an AI generated video that is being transmitted through some illegal or chokers. They produce it just for that fun, but it's actually very harmful for the person who is actually suffering from it. So this is thank you from my side. My name is Preet Patel, 24C09. Thank you.